Hi everyone. In this video we're going to talk about how we solve rational equations with rational exponents. So if you'll recall from a previous video, in order for an equation to have rational exponents, it means that at least one or more of our x's is raised to a fraction. So in this case, we have the fraction 5/3 as our exponent. So we have a rational exponent, and an equation is made up with that. So first thing is, remember that rational and fractional are interchangeable. If we have a rational exponent, it means that it's a fraction. And remember that using our exponent rules, we can actually write a fractional exponent as a radical and vice versa. So if you look at this example down here, I rewrote this term 8x to the 5/3 power as the radical, the cubed root of 8 times x to the 5th power. So when we have a fractional exponent, remember that the numerator, so in this case the 5, that's the power that we're raising x to, and then the denominator 3 is the root that we're taking of it. So we're taking the cubed root. When we solve our equations with rational exponents, it's going to be very similar to the steps we used when solving radical equations. So we're going to want to get the term with a rational exponent by itself on one side, and then we're going to end up raising both sides of the equation to the power that's the reciprocal of the exponent. And remember that a reciprocal just means that we flip the denominator and numerator. And I'll show you what I mean as we go about solving this example. But before we get to that, and a really important matter to consider is that we need to think about, okay, what if the numerator of our rational exponent is odd, and what if it's even? These are two different things. So if it is even, I have a nice little diagram here. So if it's even, that means that we're going to have the plus or minus of that solution. If it's odd, then we're going to have just the positive of it. And I will show you why. So in this case beneath, I kind of spell it out, but let's do this on the side here. So if I were to have x squared equals 4. Well, when I square root this both sides to solve for x, I end up getting that x equals the positive or negative of the square root of 4, which is 2. But if I were to have x cubed equals 8, if I take the cubed root of both sides to solve for x, I only get that x equals the positive 2. And the reason is think about it this way. If I have positive 2 times positive 2, or positive 2 squared, we get positive 4. If I have a negative 2 squared, so negative 2 times negative 2, we still get positive 4. But in the case of an odd exponent, if we were raising a negative 2 to an odd exponent, so negative 2 to the power of 3, well, that would be, let me write this out here, that's going to end up being negative 2 times negative 2 times negative 2. Negative 2 times negative 2, that gets us a positive 4. But when we multiply that by a negative 2, we end up getting a negative 8 as our final answer, which is not what we had started with. We started with a positive 8. So therefore, when the numerator is odd, so when the power we're raising our term to is odd, we only get the positive solution. Okay, so let's go ahead and look at the steps for solving our rational equations with rational exponents. In this case, we only have 3 steps. All the others we've had 4. So step 1, we're going to isolate the term with a rational exponent to one side of our equation. So very similar to what we did with our radical equations. Step 2, we need to determine if the numerator of the rational exponent is odd or even. so that we know if we have the positive and negative of our solution or just the positive. And then we're going to raise both sides of the equation to the power of the reciprocal of that rational exponent. And then the very last step, we're going to check all our solutions in the original equation. So again, step 3 is very important because, as we saw with our radical equations, which are very similar to our equations with rational exponents, we could have extraneous solutions. So let's go ahead and start with step 1. So let me rewrite my equation. So we're going to do this with, we're going to solve the equation 8x to the 5/3 power minus 24 equals 0. All right, so the very first step, it says to isolate the term with a rational exponent. So this here, I've underlined that term, 8x to the 5/3 power, is what we want by itself. So we need to undo this minus 24 by adding 24 to both sides. So we end up getting 8x to the 5/3 power equals positive 24. So now we are looking at step 2 because we isolated our, there's more that we could do to isolate this. I noticed that we have 8 times this x to the 5/3 power. So let's go ahead and divide by that 8 on both sides. And when we do, now we actually have our x term by itself. There's no coefficient with it. And we get 24 divided by 8. It's a nice 3. All right, so now looking at my equation, let me rewrite this here. We have x to the 5/3 power equals 3. My numerator is 5. 5 is odd, so we are only going to have to worry about the positive of our solution. Now, the reciprocal of 5/3 is going to be, we switch the numerator and the denominator, so it's going to be 3/5. This is the power we're going to raise both sides to. So x to the 5/3 times, or not times, to the 3/5 power. And then we're going to do the same thing with 3, raise that to the 3/5 power. Now you'll notice the reason we're multiplying by the reciprocal is because when I do my exponent rules here, if I'm raising a power to a power, we multiply those powers. So if I multiply these powers, remember multiplying fractions, you multiply straight across, we end up getting 5 times 3, which is 15, over 3 times 5, which is 15. Well, 15 over 15 reduces to 1. So therefore, we have x, or x to the first power, is equal to 3 to the 3/5 power. Now, if I wanted to, I don't necessarily have to, but if I wanted to, I could rewrite this 3 to the 3/5 power in radical form. So we could have, remember that the denominator tells us the root we're taking. So we're taking the 5th root of 3 to the 3rd power. So either way, whichever way you choose to write these are our proposed, this is our proposed solution. So we only have one. But now we have to check it. So I'm going to use my original equation, which we had was 8x to the 5/3 power minus 24 equals 0. Remember, I don't know that this x equals 3 to the 3/5 power is a solution. I'm checking that. So I'm only working with one side at a time, and then I'll compare our answers. So it's actually really nice if I keep this as 3 to the 3/5 power when I am checking my solution. So I'm going to leave it written that way. It's going to be easier to work with. So everywhere I see an x, I'm replacing that with this 3 to the 3/5 power. So we get 8 times 3 to the 3/5 power raised to the 5/3 power minus 24. Remember exponent rules. I multiply my exponents. You'll notice we have the same thing happen that we had in step 2, where we get 3 to the 3 times 5 is 15 over 5 times 3, which is 15. So this ends up just being 3 to the first power. And I rewrote everything else in my equation. So 3 to the first power is 3. I'll rewrite everything else in my equation. Remember, order of operations, we do multiplication before we do our subtraction. So 8 times 3, we get 24. And then we subtract 24. So 24 minus 24 is 0, which is exactly what we had on the right-hand side. So we get a true statement. So therefore, our solution here is x equals 3 to the 3/5 power. Or again, you could write this as the 5th root of 3 cubed. So we have one solution to our original equation. I hope you find this video helpful and wish you luck as you solve your equations with rational exponents.